Yes, I'm correct. So we're going to practice our knowledge. So this DM scheduling strategy, you are required to use a DM, the deadline monotony scheduling strategy to schedule these three tasks. Okay, so these three tasks we have tell you what's the period, the CPU, and deadline. Okay, so typically, first of all, you of course need to have your activation diagram with one or two hyperperiod. Okay, so since we already extract the information in a table, okay, but you not so sure the period, okay, so the second step should be what should be you going to scheduling, am I correct? So priority, and then for the hyperperiod, okay, so you can start to do this. Okay, determine the period and the hyperperiod. Okay, the priority and hyperperiod. So with this one, if we based on the dead monotony, so we based on the deadline monotony. So the smaller the deadline, of course, it will be the higher the priority. So for this case, we can what? We can modify it, no modify. We can reschedule so that we can figure out. So this one of course is a lowest priority, highest priority because it's a 27. The deadline is the lowest. So we can put here, and then that's me. I swap the B and A. Okay, the deadline monotony. So from okay, based on deadline for DM, okay, DM scheduling. So if RM, we're going to based on the period. So we can conclude, we can okay, the period, the priority is task task B. Task B greater than task A, and task A greater than task C. Okay, based on their deadline. Okay, so if you based on the RM, the task A is a high priority because the period is the lowest. Okay, so you have a period. Second is your period. Okay, using the what LCM. Okay. So for LCM, we still because it's a period, so you are going to you put the period in this what function. Okay. So for the first one, what is the list multiplier? I think one of you asking me this one, I got figure out using a table. Okay, so you can use a table to use your do your LCM. So first of all, you what you can say that you have a task B here. Okay, we have a task here with a B A C, and then the B the what the period. You know, use equal sign. I mean, okay, I use this one better. So the task B period is 40. So for 40, how are you going to have your 40? Okay, 40 can be equal to 2 multiplied to 5, you get 10. 10 and then multiply to 4, you get am I correct? But 4, you know that 4 is now the least multiplier. So 4 actually equal to 2 multiplied to 2. Okay, so in this case, so we can figure out that for the least multiplier, we have 2 and 5. Okay, and then for 2, we have 2 to power 3. Okay, and then for 5, we have 5 to power 1, so it's 5. Okay, so we can have these 2 multiplier to get 40. Am I correct? Okay, so you settle the first one. Second, task A, we have period of 30. So how are you going to get the 30? So you need 3 multiplied to 10. Okay, and then 10 is equal to 2 multiplied to 5. Okay, so the what? The multiplication of these 3, you're going to get, or the product of these 3 going to get 30. So you have new multiplier is 3. So maybe if we rearrange, so we should have 3 here, we have 2 here, we have 5 here. Great. So this is your task A. Okay. So the C, we have 50. 50 equal to 5 multiplied to 10. And then again, 10 equal to 2 multiplied to 5. So you have 2, 5. I mean, you 5 to power 2. So and then here you have 2, here you have 0. And then here you have 5 to power 2. Okay. So these are 3 multiplier that you can get from this question. And now we're going to select the what? The highest power. This is the highest power. This one is the highest power. For 5, and then for 3, we only have 1 power. What? To power 1. So we only have this one. So you can make a what? Make a calculation. So for this one, you have 2 to power 3, and then 3, and then you have a 5 to power 2. Okay, and then use your calculator to get 8 multiplied to 3 multiplied to 25. You should get how many? You should get 600. Okay, your friend said 600. Okay, millisecond. So we actually is millisecond. Okay, so these are the step that we use to come out our what? Our hyperpedia. Okay, okay. So you after this one you can use a Simpson. Okay, use Simpson to plot the activation diagram. So we settle this case already. Activation diagram. Okay. So since the hyperpedia is 2, so you need to need to set it as a 1200 millisecond. Okay. But there's a question for Simpson, because we are using the deadline monotony. So how are you going to have deadline monotony for your Simpson? Okay, for this case. Okay, Simpson. So set the period according to our 1200. Scheduler, we choose the early first monotony. The processor, 1 only, we add this processor here, we add 1. If you add 2, it will become multiple processor. So we do remove 1. Okay, 1 only. The task, we had 3, so we add task 1, 2, 3. Then from here we key in our period. So from this one, we have a ABC, but we follow the A first, of course. So A is 30. We can change the name. Maybe A, B, C. Okay, so here is 40. Here is 40, and then 30, 30, 40, 50, 30, 40, 50. So you can open your laptop to do the same thing. And then that, and we have this one 28, 27, and 40. 28, 27, and 40. And then our CPU time is a 10, 10, 12, 10, 10, and 12. So this what if you set it will follow something, so we are now using this thing. Okay, we done everything, so we generate the result. So this actually later we can check whether it's same as our CPU time, our simple test. Okay. Okay, and then I think we are see, okay, occupation time preemption. Okay, look like okay. So far looks like scalable. So we create the gun chart. So you can exclude or include the CPU. Okay, so here we go. This one. So our period should be copy. Print screen is one. Okay. Chop this guy. Okay. Now we see correct now. Look like slightly different because we are using the deadline first. Okay. So if we're using a deadline first, so first the lowest is what is task B. So the task B is executed. Okay. Because what of course if you want to put your task B at the top, you need to adjust when you key in the task. So if you just plot as how you key in the way you key in. Okay. But if you manually roll, so we prefer put the first priority at the top. So this one, the task B, we execute first because the deadline is lower. So the earlier that die first. So after this one will be executed. So after that, the task B will be executed, and then the task C execute. Okay. And then by right we expecting the what? The task B is executed. Am I correct? Based on our the deadline monotony, but this one is no such thing happen because when we set our deadline is from here to here. Okay, so it's a task. This one is a task A deadline. Okay, and then the deadline is from the beginning we release the task until we multiply to the relative deadline. Okay, so we get 30 you multiply this is task A multiply to 28, so you get how many? The 58, so it's here. Okay, so this is the second round. 58 will be a deadline. But for our task B we release the task when the time is 40. Okay, I mean the next cycle 40. So 40 multiplied to the deadline 27. So we have a 67 as our deadline. So that's why this caused this thing happen. Okay, so in this second round, apparently the earlier deadline is our task A. That's why the task A has been executed. So not the following is based on early deadline first scheduling algorithm. Okay, so you can understand what is the earliest, okay, earliest deadline. So that's mean in or every time the compiler going to see the deadline, okay, this means they're going to mark the deadline. So for example, the task C, the first round is okay, and then second round, the next deadline is start with, I mean, if you calculate based on the period actually is 50, 50 plus the deadline, so it becomes 90 is the deadline. Okay, so when you see this three arrow, let me can see, can change the color. No, okay, we change the color a bit so you can easily to see this guy. Okay, let me change this color. Okay, so in the next round, the compiler will see, okay, at this round, the task A, the deadline is first. Okay, so apparently, so which one you need to schedule first? It's a task A, correct? So that's why task A has been executed first. So after execute this one, so the compiler will set the new deadline. I mean, if you recalculate, you can figure out how the program will run actually, the scheduling algorithm. So that we're going to recalculate the deadline. I mean, for the third round. So the third round will be what? Will be 40 plus 40 plus this one. Am I correct? Two cycle 40 40. But this also is a two. It's a 107. So should be here. Wait, 107. Yeah. Now we're talking about the task A. So it's a 3 60 60 multiplied to this one, you get 80. Yeah, so it's this one. Okay, so you see every time after execute one task, it's going to change the what, it's going to check the deadline, which one will be reached first, and then it will execute. So after done this one, so apparently the task B, the deadline will reach first, so the task B will execute first. After this one done, so it will recalculate the task B deadline. The next deadline will be 107 is here. Okay, so at this time, if you see this round, the task A still earlier than the task C. Am I correct? So that's why the task is still not executed. Okay, but at the same time, the task A cannot be executed because it's not yet reached the what, the next round. The task A, you can see next round should be start with 60. Okay, so it's slightly complicated, but it's not that complicated. Okay, it start at 60 at the next round. Okay, the period. So that's why we are not allowed to start our task. Just like you know you reach your lunch hour, so you're not going to eat your lunch for tomorrow. I'm correct. You need to wait until tomorrow to have your lunch. Okay, so you know eat first. So that's why we still have some free time. And then at the same time, the compiler also will see what is available at the ready state. Okay, ready state. Okay, so in this case, the ready state only have task C, so the task C will be executed a bit, but then when the time reaches 60, the task A will be executed. Okay, so this is what actually happened in this early deadline first scheduling. So next is analyze the system. Okay, so this is very important. I think it's also part B in your project. So the simple test is very simple. Very simple. It's not that simple as well. Okay, actually is we need to have a summation. Okay, summation. Okay, of what, of the ratio PC, CP, C over P for tasks. Okay, so if less than, and then we have our criteria, correct? If less than 100, so we know that is what is what is might be can be what can be scheduled, but it's no guarantee. So that's why we need to compare to our what our another threshold. Okay, so it should be less than the threshold. Okay, so for this case we have 10 divided by 30 plus 10 divided by 40 plus what plus 10 12 divided by 50. Okay. So this is a slide from our part 3. So this is a criteria. Okay, so we want to see it guarantee or not the URM. So URM is a threshold, is a formula. Okay, so this is a outcome if you key in the n is equal to how many tasks. So our task is we have 3 tasks, so it's equal to 77.97. So using calculator, so we get the what? We get our total CPU utilization. Okay, the one is actually it's more than so if more than, that means we are in this case already, am I correct? So we need to run the full test. Okay, it's no less than, it's more than. Okay, but at the same time it's less than 1. So you can using this one, u equal to this, and then get this one, and then you can make a conclusion that u actually is what is more than the what the URM actually is a 77.7. S7 okay. So I think this one is we calculate here. Okay, 97 So 97%. So we know so sure. Okay, it's no guarantee feasible. Okay, no guarantee, but when we say no guarantee, that means still got hope. Am I correct? So we need to go through our what full test. Okay, what happens if the what is guarantee feasible, but I still need to do the full test if the question asks you to do them, correct? But anyway, we run our simple test already. Okay, so this is a way to conduct your simple test. Okay, and then this is our conclusion. Okay, so the U actually is between the URM, but at the same time less than. It's more than, of course, it's what is it's not feasible. So we can make a conclusion that one is not feasible. It cannot be scheduled. Okay, the one is very clear. Okay, so you can go back to maybe to memorize or familiar. I think you're familiar. So if more than, we can direct make a conclusion. Okay, conclusion. Okay, it's overload. Okay, it's guaranteed feasible if less than. If this one, no social, we need to do full test. Okay. So we complete our simple test. Now it's a full test. So full test, how you going to do? So for the full test, yeah, hopefully you still remember. So now we just maybe help you to refresh a bit. Full test, so we first of all we calculate the what the S, correct? The S, the task 1, and then 0 is our first try. Okay, equal to our C, so it's 10. Okay, and then normally the first round just okay, say just for fun. equal to S10, and then this one is less than our deadline, D. What a last time I have better framework. Okay, you should write the task B first. Task B DB your period, your CPU time, and your deadline. Okay. So hopefully you can see the deadline B actually equal to 27, so it's less than. So for sure our what this one is scalable. Okay, scalable. Okay, because it's less than the deadline. So and then every time we will going to run our task B first. So of course the task B not going to miss the deadline. Then we have our task A, the second round. DA. So this one should be the subscript. Subscript here. So that's why sometimes handwriting is faster, am I correct? So 30, 10. So again, any question just post in the chat box. Later I will go to the question. So this one is our second round. So we are actually, as I mentioned last time, just like programming. 10 millisecond. Yeah, it's a millisecond. Equal 10 millisecond. S21 equal to, okay, now we need to consider our previous task. That's mean we have what? We have this CA. It's quite confusing a bit. This one we remove, make our thing smaller, bigger. Okay, so C2 plus C1 with a ratio. So this one is a ceiling. The ratio is ceiling, so we use ceiling up a thing. So it's a S20 divided by your P1. So where's the P1? So this is a P1. P1 equal to this one. C1 equal to this one. Okay. So so it depends to the scheduling. So we always start with the highest priority task. In case. So what's the answer? C2 is this one. P2. C2. And C2 we get 10 plus C1 10 as well. Okay, ceiling up ratio we use this and this. Then divide by P1 40. So we get 0 point something, so we setting out become 1. So we have a 10 plus 10 equal to 20 millisecond. Okay, so this one is no same as the previous one, so we need to run again until it reach the same value. This means whole thing we need to repeat. So you can update, we can S22 This one's still the same, but this one refer to the previous one. Okay, S21. Okay, everything are the same. S21 just now we have 20, am I correct? 20, everything same. And then since we setting up, this one you get 0.25. This one you get 0.5. Setting up you still get that one. So you get the same amount. This is equal to the S21. That's means equal to the previous one. So you can stop here. And that is less than, oh no, I mean less than the DA equal to 28 millisecond. So it's still scalable. Okay, so that means the second task you're not going to miss any deadline. So settle. Next we have our task C. Okay, task C, DC. Okay, DC we have a 50, 12, and 40. Okay. Again, we do the same thing. It's a scalability test for the second higher priority, the third priority, third task. Okay. First round, we just record their CPU time. This again. Okay, is 3.1 equal to C1. C1 should be C3. C3. This means it on. Okay, itself. Okay, this means it's on CPU time plus the previous priority task. This one is a C2. Okay, also plus a C1. But each of the previous tasks you need to compare their ratio. I mean, need to multiply to a ratio. Okay, divide by the P2. Okay, can you see the pattern? It's quite easy to memorize, am I correct? Because all of them they have the meaning. Okay, it's not just simply ask you to memorize something. Okay, if you go through this one, you can from here you can see what actually happened in your activation diagram. Okay, so we come out the formula already, and then now we substitute the value 12 for the C3. Okay, this one is C3. So P3 no need to do already. And then C2 we have 10, am I correct? 10, and then the ratio 12 divided by P2. P2 is 30. That we plus 10 multiply to 12 again, divided by is P. P1 is 40. Okay, and then we save some space as well. We give 32 millisecond. So 32 millisecond still less than the what? That's the DC. But you can just continue because we don't yet reach the what? You don't yet get the same value as the previous one. So you copy the whole thing, you repeat the whole thing, except you refer to different S3. So now in this one you refer to S31. This one also S31. S31 12 plus 10. Okay, S31 is 32 divided by 30. So you get 1 point something. So 1 point something will make it more, make it 2. Okay, 1 point something will sealing out become 2. And so this one still 0 point something, so it will be sealing out become 1. 240 12 plus 20 plus 10 plus 8 plus a third equal to 42. Okay, basically look like we can stop already. Why we can stop already even though we are no reach the same thing, because actually it's more than the deadline already. So it's not schedulable based on this one. Bigger than the DC. No schedulable. Okay, so in conclusion, if you're using a DM, it's not schedulable for this this task. Okay, you're going to miss a deadline. Even though it's still within the period, still less than 50. Okay. Because the deadline is what is 40, then this one is 42. It's missed the deadline already. Okay. So I think we can try the activation again to prove our calculation. It will be more interesting. Okay. I think this one I've done before already. Okay, maybe I redo again so easy for you to recap. Okay, so how are we going to roll this guy? Of course, we need to have a table. Okay, this one we copy. And then we come out. Okay, because based on our calculation, we going to hit the deadline. It's around 42. But you know that just now we during our calculation is 600 something. Am I correct? But in our calculation, look like we can come out we can see this thing happen at the time 42 around there. So I plot maybe until what? This one is 12. Plot 10. Wait, this one too small. Row with 4. Can make it 4. Okay, something like this one. Okay, not so good. 4. Then this one make it 12. Make it 10. Okay already. Okay, something like this one. Then redesign a bit. In your final, you don't need to do this thing, am I correct? Because you have a you have a paper, so you can handwriting. So of course, first we label. We have a task B here. Task B, task A. This one just for us to see this thing, but in your exam, if you're required to schedule 2 hyperperiod, you need to plot 2 hyperperiod. But of course, hyperperiod should be not 600 something, should be just less than 100. So here we start with 0 time. Okay, 0 time. That we have this as we label as 10. And 20, 30, 40. Slightly far away already. 50, 60, 70, 80. Okay, something like this one. Never mind, you understand, correct? Okay, Next, we mark the period. Okay. Copy. Okay. So since all the tasks start at the time 0, so all start at here. Then the task B, our period is 40, so should be here. Next round should be 80 here. Next, our task A, 30, so should be here. So let's between this mark, we're going to run at least once. 60 and 90. Task C, 50. Okay. And then we need to mark the deadline. Deadline we use what? We use this symbol. Okay. Look like not so serious. We maybe use arrow. So they look like a bit. So this is a deadline. We need to finish before this flag. So first one we have a what 27 should be around here. Okay, cool down a bit. Okay, and then the task, the second round is after release time. Release time to you should turn. I mean, if you based on Simpson use this one. They have a release time as well. So now we assume they are same, so we don't need to mark. So 40 plus 27, so it should be here. Okay, 40 plus 27. Okay. Next we have task A. Task A is if we start with 0, 0 plus 20, add us around here as well. Next is from here 30 plus 28, so it's here. Okay, around here. That 60 plus 28 around here. Okay. Okay, so next we have task C is 40, so it's much easy to mark for this one. It's 40, easy. And then this one 50 plus 40 we get 90. Okay. So this is a relative deadline, so it should be right as a relative deadline because there some of you ask me what's the different deadline and relative deadline. The relative is the deadline should be the time, right? So for example, the deadline to submit your assignment is 10 o'clock. 10 o'clock is your deadline. So if when we start the assignment, it's not so good. I mean a quiz, okay. For example, the test. The test will start 9 o'clock. The relative deadline is 1 hour. So your deadline is 10 o'clock. Okay. So deadline is more actually is the timer. But if you are not mentioned, so it should be the relative deadline for this case. Okay, we set those things. So next we finish our CPU time. So step 1, marking period and priority and deadline. No, this one should be a step 2. Step 1, one, a marking again, marking Y and SSA. Actually, sometimes the step is too simple, but it's important, right? Just like the first step to do your final is to read the question, am I correct? So if you not read your question, how are you going to do your exam? Okay, so fin CPU time, and this one is 10. So 10, how big of a 10? Okay, so this is 10. It's quite okay. 10 until here. So then copy place. This one is 10. Now we assume that the release time is 0. So we settle the first task. So don't just fit in together from highest to lowest priority task. Okay, this one I settle. And then I find the second priority task when the CPU is free. So this one is CPU free. After time equal to 10 is free. So this one also 10. So I can fill in 10. Copy, place another. After release time is here. Okay. This one. Because empty, am I correct? There's not any CPU at the time 30 to 40. So I can run this one. Finish this one. Finish. Okay, looks like very nice for this first 100 millisecond. Yeah, sometimes if the exam, if this case maybe, if this is your exam question, maybe they just ask you to come out your activation diagram for the first 100 millisecond. Okay, also possible. So that's mean if you found that the exam look like ask you to do something illogic, so you should ask a question during your exam. So I can help you to take a look. Yeah, you see this one, 10, but I still have 2, am I correct? 2 millisecond. But there's not any way I can do this 2 millisecond. Okay, before deadline is here. So that's why this one in our calculation is stated that at the time, the time 42, am I correct? We missed the deadline. Yeah, I should change the color. This color is not so nice. Okay, change a bit the deadline. Deadline should be red color, correct? In become red. This one CPU. What color you want for CPU? Maybe something green. Format here. Green better. Okay, so we missed. Hey, this one no yet. So we missed the deadline. Copy, paste. So maybe the purpose for this is to show you that we do miss the deadline sometimes. Even 2 milliseconds is still missing a deadline. Miss the deadline. Okay, clear. So if we compare this one to our calculation, so our calculation clearly show that you're going to miss the deadline here, am I correct? So that's why full test is very important. Without the activation diagram, it can help us to figure out whether we miss the deadline or not. Okay.